Hey all, I'm Shivan.
I'm Anton.
And we're here to talk about how we ship content blocking to 50 million users, actually 60 million users as of this month at Brave. And we do a lot of privacy-focused stuff at Brave, so it's really cool to be here, to be around like-minded people. So just a quick note before we get into it, when we talk about content blocking, we mean ad blocking or tracker blocking, as people call it. It's more kind of use these terms interchangeably. So the talk in a slide, we're going to talk about why ad blocking is important for privacy in particular, and not just cosmetic filtering, and also talk about why it's hard to maintain the engine that powers this. And also we'll talk about the challenges that we ran into while shipping this to millions of users and how it's kind of a unique thing in the ad blocking community, and also mention, and also we had to do a bunch of research because a lot of these problems were novel. And yeah, also talk about how it was really great to be able to leverage a community project for this. Cool, so who uses ad blockers? A lot of people. And this was an IMC study in 2016. I'm sure this number is even higher now. And not just for ad blocking, like I said, also for privacy. A lot of people have acknowledged this, including the NSA and the US Cybersecurity and Infrastructure Security Agency, mainly because, with an ad blocker, you get network traffic filtering abilities on your own client, so you can block a lot of tracking scripts and just prevent a lot of network exfiltration. But importantly, from a client point of view and not a network admin point of view. So just quickly step through what it means, what we are talking about when we talk about ad blocking and what that looks like in practice. So you go to a random website and you see an ad down there, and you would like to not see that ad. And it turns out that that ad is inserted by a script, and that script has a name called expads-blocked.js. So this would be a filter rule. You would add a filter rule like this to your ad blocker engine. So basically saying that if you load a script that matches this name, then you should block it. And then that's how the ad is blocked. And in Brave, if you look at DevTools, you'll see that that script actually shows up as blocked by the ad blocker. So this kind of brings us to the question, what are filter lists? They're simply collections of rules, the same kind of rules that I talked about in the previous slide. And the two biggest examples are EasyList and Easy Privacy, the two, I guess, most actively maintained over like decades. And this is kind of what it looks like, just like thousands of rules in EasyList and Easy Privacy, and these are fed into basically every single ad blocker that exists. So Brave, ABP, AdBlock Pro, or uBlock Origin. Chromium also uses EasyList for figuring out which ads are acceptable. And AdGuard, so yes, if you've used an ad blocker, you've used a filter list. So this brings us to the question, why are they hard to maintain? The biggest problem that we face is that, or the community faces, is that rules go obsolete like all the time. So very simple example of this is that the name will just change. So instead of being called expads-blocked, it's now called expads-datetime. This could be benign because let's say the website operator just changed their ad library, or it could also be malicious because they're trying to actively get around ad blockers. But the point is that our ad blocking engine has no way of figuring out what thing to block now. So yeah, so the ad now exists again. And this is problematic. And if you think about the ad that we saw in the previous slide, like that's kind of obvious. A user can see, oh, my ad blocker is not working, which is not great. But I think it's a much more serious problem that a lot of the invisible tracking scripts are now running even though the user thought that they're safe. So they're kind of worse off at this point. And you can't just block add star.js because you will end up breaking most of the web. So an ad blocker can't really do that. We have to be extremely particular to the, specific to the script or resource that we're blocking. It's also kind of uniquely bad for a privacy-focused product to face this problem because we're shipping ad blocking, and if the ads don't get blocked, that's kind of a problem. So the question is, and the problem that we were facing was, how do we identify adblock evasion? And this was an open problem. And the solution that we kind of came up with was, what we're really looking for is not names, it's actually how the script executes. So what we ended up doing was, we create a signature of the tracker script as it executes on the V8 JavaScript engine on a loop-by-loop basis. And from that signature, we can then run a web crawl or a web measurement study, and you can use that to catch similar scripts that were just obfuscated or renamed or inlined. This was pretty successful. We presented it at IEEE S&P last year, and we also shipped new filter list rules based on the measurement study that we carried out. I contributed this back to EasyList and Easy Privacy. So we come to the second problem, which I think is a much harder problem to fix, just generally for, I think, all web browsers is that care about privacy, is like, how do you prevent website breakage across the web? Because these rules can actually break websites. And now let's step through some code, which is always fun in a live presentation. But this is a simple web page, so it should not be too bad. So it's an HTML page, and it loads an evil.com track.js script, which we want to block. And but the way it's set up is interesting, is that it calls track user, which is the privacy harmful function that we want to block. But it passes in a benign and a good function called setup page as a callback. So this is a problem because what happens if you just block track user, you will actually break the page because setup body in this example will now no longer be set up. So it's not as simple as just blocking track.js. You're going to get a reference error, and the whole page breaks. So you block the ad, but you also block the website. So this is also extremely bad, as you can imagine, for a browser if we break web pages. That's kind of the thing that people use a browser for. So retaining and acquiring users is crucial, especially as a young privacy-focused project. And also, I think how we differ from other ad blocking projects is that we don't expect users to be technical. We would definitely not scale to hundreds of millions of users if that was the case. So ad blocking, and generally like all of our privacy protecting mechanisms should work out of the box. You should not be expected to know what a filter list rule is, or what easy list is, or what any of these things mean. You should be protected by default. And also we have a lot of users, and this is true for a lot of the folks here. We have users in places where folks don't have the latest hardware, and we can't just say, we don't care. We actually actively care because that's where our users are. So we have to think about compat across the scale of the web. So the solution to this problem was creating privacy-preserving script replacements. And what that means is that we generate, again, based on JavaScript execution, we generate a privacy-preserving version of the bad script. And in this way, we kind of solve for the privacy versus compatibility trade-off, or privacy versus utility, as it's called, generally. So we solve for that trade-off by automating the creation of the privacy of the bad script. And what that looks like is that in the previous example, now instead of loading track.js, we load a sugar-coated track.js, which is essentially all the privacy harmful accesses, such as cookie setting or any kind of bad thing that we might want to block. We now create a stub version of that script. So now when you call the tracking function, all the API accesses for that script look the same. So the website still thinks it's calling track user on track.js, but actually it's calling a local resource that has been sugar-coated, and that's actually not harmful for the user. And we don't break the callback and all of that stuff. So the page actually would get set up correctly. And this paper was presented at CCS last year. And we shipped it, but we did run into some issues, which was kind of interesting because the research prototype exists, and we were like, great, fantastic, let's ship it. We did some browser engineering, created a bunch of resources, and we were we were careful about the fact that we knew that we couldn't just ship like 1,000 megabytes in every single browser instance, but we rolled out slowly. But it turned out that on devices with low RAM, or low available RAM, the browser still ended up crashing when it was trying to load like hundreds of scripts like at runtime. And this we tested on local beefy, I guess, devices and CI, but we never ended up testing on devices with where the browser is not the only thing running. There's other stuff running as well. So this was a problem, and we ended up having to roll back. But now we know that our perf testing has to be a lot more robust for making sure that we scale across like a lot of different devices and hardware. So yeah, so that's kind of what we do from a research and development point of view. Anton's going to talk about how we support the filterless community. We have taken essentially an open source community project, which was EasyList and Easy Privacy, and we're using it, but we also want to make sure that we build trust with that community and give back. And that's actually a superpower, I think. So over to you, Anton.
Yeah, thank you, Shivan. So yeah, obviously there's a lot of research and engineering that goes into building a product like this. But again, we're building on top of ad blocking, which is very much a crowdsourced thing. So there's a lot of work that goes into the community. And so one thing that we do at Brave, which is awesome, is I don't know if anyone here has been looking into ad blocking at all, but if you have, you've probably heard of Ryan Brown. He's kind of a legend in the ad blocking community. He basically maintains EasyList and Easy Privacy. And so he's been doing that since basically before GitHub indexes contributions. So I don't even know how long he's been doing it. But we ended up hiring him in 2019, and that's just a great way to kind of give back to the community. We're sustaining the efforts of filterless maintainers and making sure that some weird circumstance isn't going to bring this whole community crashing down. Of course, there's plenty of other filterless maintainers, and we're extremely grateful for what they do, and we try to support them as best as we can at all times. And another thing that we do at Brave is we keep a very close watch on feedback channels. So we look at GitHub and Twitter and Reddit and our own community forums. And every now and then somebody will post a notification saying that, hey, look, something is broken on this website in Brave. And we do our very best to go ahead and try to get a fix for those within a day. We can push new filterless rules to everyone, and basically, if we can get that fixed in a day, they're usually extremely happy about it, and that's great for us because they might come back and support and give us another report of something broken. So that really helps us to stay on top of web compatibility fixes, because that's one of our quickest ways of finding something across the entire internet. Of course, there's also our nightly and beta channels. So that's where we actually ship new browser features before they make it to the release channel. And we have a few power users who are on there, and they really like to see this kind of first sneak peek of new privacy features that are coming up. So they often are pretty technical, and will post on GitHub if something's broken there too. So that's great to have. Of course, as a privacy company, we don't want to force users to post on social media if they're having an issue with a website. So we actually ended up building out this in-browser reporting system where it'll send the URL of the page you're on if you choose to use it. But otherwise, all this data is like completely opt-in, so you can add as much or as little information about the page breakage as you want. You can add an optional follow-up, either email address or Twitter address or anything. It's just a free-form field. And we do our best to stay on top of those. We get actually about 2,000 reports per day through this system. But Ryan and a couple others do a great job of staying on top of this and building out nice dashboards and things so that we can actually filter through this data in a meaningful way. So yeah, okay. Ad blocking works using an ad blocking engine, basically code that will parse filter rules and be able to match on them really efficiently at runtime. And so I personally maintain adblock Rust, which is Brave's ad blocking engine. But just because I maintain our ad blocking engine and other ad blockers use different engines doesn't mean that we are competitors or working against each other. It's really a community effort. And so, like, I've personally filed issues against uBlock Origin and Clix's ad blocker and AdGuard, and being able to get minor incompatibilities between engines fixed and fixing security issues and things like that overall just really helps the ecosystem as a whole, because if you have a fragmented space and every ad blocker is doing something slightly different with the same set of rules, you're going to create a lot of fragmentation, and there's only so much effort that can go into filter list maintenance, so making sure that that's all working the same way is really useful. And another awesome thing about Brave is that we have a really strong open source culture. So everything from our adblock engine to the lists we use to the resources that we ship as replacements for things, for scripts and images and things like that. And of course, the whole browser itself, that's all open source and freely licensed. So what's awesome is that we've actually had third-party browser projects coming in and using our adblock engine in their own browser. So you might have heard of Qt browser, which is a kind of Vim-focused key binding browser, very minimal. And then Angelfish browser is a Android browser replacement. So those both use adblock Rust, and developers from those projects have filed issues and PRs on adblock Rust, and that's just really helped to make it more robust, and having the development in the open kind of helps everyone there. Again, with the SugarCoat resources that Shivan mentioned, we weren't ready to ship those in the browser immediately, but we basically open sourced them as soon as we published the paper, just to make them available to the broader privacy community. And even now, we're not using all of them quite yet, but they're all available for people to use. So yeah, I'll give it back to Shivan to kind of close it up here.
Sure, yeah. Basically, just wanted to have the slide up while people ask questions. Yeah, so privacy is meaningless without compatibility. It doesn't matter if your product is the most privacy preserving if it doesn't work. So and I think the interesting thing is that, like, we talked a lot about trade-offs, but I think there's often like this low-hanging fruit and maybe not so low-hanging fruit in research to get best of both worlds. So I think we should be investing in that research. And shipping research is hard. Make sure that you have a rollback plan and make sure that you perf test. Yeah, it's really important, like Anton said, to set up feedback channels so that you get quick feedback on, especially when you're shipping like a little bit more sensitive or a little bit more, cutting edge privacy stuff, then it's really important to hear from users if that is actually breaking their use cases. And they love it when you, fix something really fast as opposed to saying that it'll be in the next release, which is 3 months from now. Good luck. And also, I think this is really important. I think it's really important to build trust with the community by hiring and supporting and contributing back. And it's ultimately better for everyone if there's more privacy on the web. And that is it. Those are our socials. Happy to take any questions.